Welcome back. Today we're going to be looking at XML in Python. But before we look at it in Python, we kind of need to know what XML is. So this stands for Extensible Markup Language, which means you can add to it very easily because it's extensible. It's designed to store and transport data, so it doesn't actually do anything. It's there to save data, a lot like JSON, which we've looked at before. It's human and machine readable, which means that looking at it, you know what it does, but a computer also can figure out what's happening. And it's self-descriptive, which is partly why it's human and machine readable. So XML has lots of similarities to HTML, but there are some differences. So XML was designed to carry data, whereas HTML is all about the presentation. And XML doesn't have any predefined tags, you just make them up, which I guess means that they're all correct. But what about the format of XML? Well, it describes data in a tree, a lot like HTML, and all documents have one and only one root. A prologue, which tells you that it's XML, is optional. All elements must have a closing tag, except the prologue, which is special. The tags are case sensitive, which is unlike HTML. Elements must be properly nested, so you can't open something and then open something else and then close the first thing and then close the second thing, so that doesn't make sense. And attributes must always be quoted. And to do this in Python, you use the xml.etree.elementtree, which is the elementary XML API. So before we write any code, we should probably have a look at some XML data. So this is just an example file. It's not the best example because it doesn't have any attributes, but we'll have a look at those a bit later. But you can see, for example, time zone has these attributes, and we can actually close that and see that this is part of the country attribute, and likewise the same with the translations. And note that this data doesn't have to be ASCII, so you can see here we've got some Unicode characters. And this here does have a prologue, which tells you that it's using Unicode encodings, and it's UTF-8, which is how we can get these special characters. So first, if we're going to read stuff, we can import xml.etree.elementtree as et, and this is the standard name for it. And we're going to just say that our tree is et.parse data.xml. So we're just reading the data from this XML file, and we could just print the tree. And you can see we have an element tree object, so that's not that exciting. So then we can find the root. So the root is the tree.getRoot, and you could print the root. And you see we've got this element called countries, and actually that's the name of our countries. And we can look at the root's attributes, but it doesn't have any. So what we can say for child in root, because you can just iterate like this. You can also use indexing as though root is a list, even though it's not. We can print the child.find name, so we're just looking for the name, and you see, this one has the name Afghanistan, this one has the name Ayland Islands, and we actually want to print the text rather than the actual node itself. And you can see it's just printed out a list of all the countries in this document. But what we're going to do is we're going to take the data and we're going to transform it so that instead of just having a list of countries, they're organized by regions. Because you'll notice, for example, Afghanistan is in Asia and the sub-region is Southern Asia. And if we scroll down a bit, we get to Armenia. So we haven't gone down that far because they're done alphabetically. We get that the region is Asia and it's Western Asia, which is the same region but different sub-region. So we'll leave this, we'll keep the root. And so we're also going to filter out some of these attributes because we're not interested, for example, in what the top level domain name will be or the currency symbol. But what we are going to keep is we say the useful is the name, the phone code, the capital, the currency, the latitude, and the longitude. And maybe others of these are useful, but I've just picked a few. And we're actually storing this as a set because we're going to check if something is in it, and that is quicker than storing it as a list. But because there are only a few items, it's not going to make much of a difference. So our new tree, we need a new root, and it's going to be an et.element, and the tag is going to be regions, because we're going to display it by regions rather than like this one, which is by countries. And we're going to say for country in the root of our original tree, the region is the country dot find region dot text, and likewise the subregion is the country dot find the subregion dot text. And some of these, for example, have no region, so you can see Bouvet Island has no region and no subregion. Even though it has a longitude and latitude. So we're going to just ignore these places because the reality is that they're probably not very significant places if they haven't got a registered region. And people from those places might think that's unfair, but we're just going to leave it like that. So if not region and subregion, so it needs both, we'll just continue and ignore the place. We could obviously add some unclassified region and just put everything in there, but we're just going to ignore them. And so we need a node, and that's going to be the new root dot find, and we're going to look for the region, a node called region, and we're going to say the location needs to be equal to region. And here I've been using an XPath, which is a special way of searching, just to say the region needs to have this attribute location, which is equal to region. And we'll say that if the region node is none, it doesn't exist yet, because obviously if we start with Afghanistan, the region is going to be Asia, and we're going to say, are there any any regions where the location is Asia? And there aren't going to be any, so we actually need to create that. So we're going to say the region node is et.subelement, and you see this one has a parent, and the parent is going to be the new root. The tag is going to be called region, and we need to set the attribute equal to location region. And then at the end, when we've done everything, we're going to say the tree is an et.element tree, and we're going to have new root as the root, and we're going to just write the tree to transform.xml. And so we can just open transform.xml and format it so we can read it. And you can see it's created these 5 regions: Asia, Europe, Africa, Oceania, and Americas. And they've all got the location tag. The thing that this is missing though is a prologue, and we can just add that in by saying XML declaration is true. And you can see now there's a prologue using ASCII, because we don't need to use UTF-8 because there aren't any special characters. But along with regions, we want subregions. So we can just copy and paste this, replace the word region with subregion, and then make some changes. So now we're actually looking in the region node rather than the subregion node. We're still going to call it location because that kind of makes sense. And the parent is now going to be the region node rather than the root. We can do the same again. Format it. And so if we look at Europe, for example, we've got Northern Europe, Southern Europe, Western Europe, and Eastern Europe, which is a comprehensive way to describe Europe. Whereas, for example, Oceania is a bit more descriptive. But now we want to add something to that subregion node, and we want a country node. And you'll notice that I'm calling these nodes, and that's because the XML is a tree, and so calling them nodes makes more sense. We could call them children because they are because it's a directed tree, but I think nodes is a nice way of describing them. We need another sub element, and now it's going to go in the subregion node because we're saying that the country belongs to a specific subregion. And then we're going to say for node in child, for node in country, it's going to loop over all of these things here. And say if the tag of the node is in useful and node.text. So if it doesn't have any text, we're just going to ignore it. Then we'll say country node.attrib, and the attrib we're going to say is the node.tag. So we're now reformatting it so that these attributes come as part of the tag rather than being part of the children, and that's going to be the text. And you can see something has happened because we've got a lot more XML. And if we format out, we can look firstly at Southern Asia, where we've got Afghanistan, and we've got the name, the phone code, capital, the currency, the latitude and longitude. And if we loop through all of these, we've got all the countries that had these data. And you'll notice, for example, the subregions are closed like this, whereas the others are closed like this. However, the fact is they are all closed, which makes it valid XML, and you can see region closes there. So we've managed to take this data, which is very useful, but I don't think as nice as this new transform data, which has all these attributes about the countries and regions. So you can see XML is a great way of storing data. It's very similar to XML, and it's very common to use data stored in XML and then to take that and transform it into something more presentable with HTML. It's also very readable, especially when you format it, and easy to handle in Python using the XML eTree element tree API. So hopefully you've enjoyed this video, learned how to format XML, and I'll see you again, same time, next week. Till then.